So I made this pool table house rules sign using flip dots. I guess they're technically not dots because they're long, but bars, I guess. This came about because I always liked the idea of a house rules sign, but there are many variations to some rules that I don't really like the idea of being locked into one set of rules, and I feel like as long as everybody can agree, who cares what you play? So the sign accommodates that. We have buttons on the side here to change the rules. So you can come in here and press these and they flip back and forth. If you like a certain league set of rules, you can come down here and press that league and they'll all flip to match that league. If we kind of like mix and match it so that it doesn't really fit any of the leagues, they cross out. If you happen to just press the individual ones to match a league, it will set that league there. Also, it was brought to my attention that legal jumping is not allowed in APA rules, I guess, unless you're a master. I am going to let that one slide because I really like jump shots. So whatever, it is what it is. Oop, just kidding. We went ahead and added in legal jumps into this thing. So now if you select APA rules, legal jumps are no longer allowed, and the other ones are allowed. One other thing we did to this is we were actually playing pool with some friends, and my nephews, my little nephews were there. They're kind of young, and they really enjoyed coming over here and like pushing all the buttons while we were playing. And so we were trying to, whoever's taking a shot had to make sure they played by the rules at hand, which were constantly changing. So it made it a little fun and interesting. From that, the suggestion from my friend came to put this randomize button, which just randomizes the rules. I don't know, really it's just for fun, but go ahead and push this and they'll just kind of randomize. If they do end up lining, that the rules end up lining into like one of the rule sets, that thing will flip, just so that you know that it said it that way. But anyways, the rest of this video had already been recorded several months ago before we updated this thing to have that rule set, and so the rest of this video will be without this. We have a lock switch here, so we can go ahead and like lock it. Really this just turns it off, but that way nobody can come in here and press buttons and change the way that it is. However, these things you can still like, you can like manually flip them, and so if somebody were to come in here and manually flip a bunch of these, when you unlock it or turn it back on, it will reset itself to be the way it was. And that's about it. Really, this thing's just a lot of fun to play with. But the rest of this video will go into how I built this and kind of the problems that I ran into. And at the end, we'll just do a bunch of sloppy sounds because the sloppy sound is so much fun. But yeah, we'll go ahead and jump into how this was built. Okay, so I'm going to kind of go over my process here in figuring all this stuff out. I did a bunch of research on the internet. It was honestly kind of hard to find a lot of information on this stuff. I mean, there's like a bunch of people that have built some, and you know, they use like a rod that's, I mean, they basically make an electromagnet rod with some wire wrapped around it and send a current through it, and it, you know, magnetizes it one direction, they swap the current, magnetize it the other direction. But I couldn't find like a ton of info on like, I don't know, how long this thing needed to be, what wire size, like the different, you know, I don't know, a lot of stuff like that, like very specific stuff I couldn't find. I could find general stuff, but specific stuff was difficult, so I had to just kind of play with it. On the internet, I saw that soft iron is one of the best materials used for magnetizing stuff, so I bought, well, let's kind of go back a little. A lot of people use these like 3M rods, 3M threaded rods, and they work. They work pretty well for their application. I kind of didn't like the 3M threaded rod because I read that the windings, the wire windings are just a lot better if they're very tightly packed, and I noticed people struggled to get a very nice tight packed winding because of the threads, even if they wrapped it in tape or whatever. So I went with a soft iron rod, and I threaded them myself using a threader, right? And so I threaded the ends to get a bolt on both ends, just tiny little bit on this end, a lot more on this end. This is one of my first ones. This is actually the soft iron one, and I guess this guy with a washer, you know, goes on there. Didn't thread the bottom for the very first one, but I probably should have. And this worked. I mean, it worked pretty decent, I guess, but a couple issues I had were the soft iron was pretty expensive. Soft iron rod was pretty expensive. It was like 16 bucks for like a short length, and I could only get like 4 of these things out of it. So I went with some steel. Just got like a round steel bar. I mean, I think steel's basically a lot of iron anyways. It was a lot cheaper. I think it was like just a couple dollars for this big length, and I didn't really notice much of a difference. I mean, maybe there is, but visually it kind of seemed the same. And so that's kind of what I started with. And so my first test, I don't have anymore, so I'll just put up a video that I took of it, and here that is. And I'm just like holding the thing, and it worked. So then I laser cut a little box to hold it all in, and that still worked too. And here is that video. I am just pushing. I just set up some buttons so that they reverse the current. There's no Arduino or anything. I just hold down one button for ground, one button for 5 volts. I think I'm running 5 volts from. And then the other 2 buttons just swap that, and that worked too. But one issue I had with that was I started with kind of a longer length like this guy here, and the box ended up, I think it was, I mean, this one, I did end up threading. I mean, this was pretty long, right? So then I made some shorter ones and threw them in a box, and the box was kind of long. I wanted to shorten it, so then I don't know, just started shortening this thing and came up with these guys, see if that made a difference. And it didn't really seem to make a difference. Maybe it does, but none that I could tell. I kept this length the same just because it was easier to have it the length of electrical tape, right? So I didn't have to like cut the tape or anything, so it's just easier to like wrap around it, not have to change anything. So one thing that I noticed that in a lot of like mass-produced Flipdot things, the Flipdots keep their polarity, and on mine they do not. They don't flip back after there's no more current. I mean, the magnet does stick to the metal bar in there, but it doesn't keep its current or its polarity. So I looked into that a little bit. Couldn't really find a ton of information on it. I saw this one video here that I'll put up, and I'll put a link for all these videos that I looked at. And this thing had like this little tiny bar on the bottom. I wondered if that made anything. So here I made a bar, and this is also iron. Actually, it might be steel. I can't remember. This actually seemed to kind of hinder it. I mean, again, it's so hard to tell, but visually it didn't seem as snappy. Also, it was a lot of work to thread these guys, and getting the distance right was like impossible, so you can see I had to like bend this out. So I scrapped that pretty quick. Did not follow through with that. I don't know, I played with a couple things, wire size, number of windings, and the windings, I didn't count my windings. I used a drill to wind them up really quick, and I was not going to count them, so I just counted like layers. I did like, I think I started, I think these are the first like real ones I did, and those had like 3 layers. You can see they're kind of thin. And went to like 4 layers, 5 layers. I think these are 5 layers. Tried like 32 gauge wire, 28 gauge wire. Like, I guess 32 gauge wire, like the smaller the wire, you get more resistance, you get more kind of force out of it, given you have more windings to kind of like meet the same size as the thicker gauge one, I think it is. The 32 gauge wire, I did get a higher resistance and it did seem a little bit stronger, but it was just harder to work with. I had to use a lot more wire, and the 28 gauge wire was pretty easy to wrap around these things pretty tightly. So I scrapped the 32, stuck with the 28 gauge, and I'll go a little bit later over about actually how I built these and wound them up. Often when people do flip dots, they do it kind of like this. We've got a round circle dot, and there's like a cutout here. So there's two magnetic poles behind this thing, and this also has those. But there's 2 poles that get magnetized on each side of the dot, and there's a magnet in there, and one pole gets energizes and flips the magnet over the other side. Most people have like a cutout in their dots. That way, this whole thing doesn't really stick out past the size of the dot, and this cutout will allow itself to rotate under and not catch on that pole. I chose not to go that route because I have text in my dots or bars or whatever, and so if I had like a cutout here, it would kind of get in the way of the text. So I just chose a bar with a tab on the end, and kind of like this. And so this edge here will be allowed to like rotate down and not get caught on that bar, and this tab will flip over and land on the bar. I went through several iterations of this, here being the first, with the magnet fully outside. But this tab gets so big, and I don't know, it took up like a lot of space, and it kind of would have like gotten into the text up and below, and so I started going through several iterations of like bringing that in, which we can see here. Got like, this one sticks way out, the magnet is fully out, and then you can see that one, the magnet's like half out. This one's like only a quarter out, and this one, the magnet is entirely inside. These all worked like with just one rule, but when I had multiple rules next to each other, these ones that were like a lot further in would be affected by the rule next to them. And so I kind of went with this middle ground where the magnet is a little bit more than halfway out, but I don't know if you could really see that. The tab itself is actually pulled in a bit so that the tab matches more this kind of like 1/4 out version. Magnet is this way, tab is that way, which is these guys, and it worked pretty well. So that's what I ended up with here. One thing when I was looking at this, I think a lot of people made their own H bridges, multiplex some H bridges to drive multiple dots or whatever. Use multiplex H bridges that they built out of transistors and resistors, and I was trying to decide how I wanted to go about doing that, and I saw some comments on some videos. There's one guy that I referenced a lot. I'll put his video up here, and there'll be a link to this as well. And he multiplexed some H bridges and kind of went about all that, and so there's that information. But I guess per dot, it was maybe, I don't know, maybe it could be a lot cheaper. I'm not really sure. I didn't go this route. I didn't try this, so I don't know, but it seemed maybe a little bit pricey. It was going to be like, with all the diodes and transistors and all that stuff, it's going to be just a little bit pricey per dot. And in one of his comments here, somebody suggested just using a motor driver with this guy here. So little 298 in. I mean, these guys were, I think, like $2 a pop. I can drive 2 dots, so that's like $1 versus I think it was like 3 or 4 or something, maybe even more. I can't remember exactly, but it's way cheaper, and it's already built for me, and so I just went with these guys. Didn't even try the multiplexing the H bridges. Not to say that that wouldn't work, but I didn't go that route. Yeah, and so this is kind of where I ended up. Let's power this guy on. Okay, so these are the smaller magnets, and they just don't really stick. They are mostly above the poles, but yeah, they don't really stick. And I was still getting, let's see, I was still getting some kind of interference, so there you go. Which is not good. And I don't think that's necessarily the distance. I think it's just more that this wood is too thick, so they're too far away, so that they can't just really grab onto those poles. So I went back to the bigger magnets, and these guys, they really, I don't know, they just work a lot better. They really stick, and pretty solid. They don't affect each other. Guess we can go over this a little bit. I mean, it's not too crazy. It looks crazy, but it's not too crazy. I just multiplexed the buttons. It's a 4x4 multiplexer. Power for this drives these 4. Power for this drives these 4. Power drives these 4. I only have 13 buttons, so I guess I could have gone with like a 5x3 for 15. I mean, there's no magic number for 13, but 15, or 5x3 for a 15, 4x4 for 16. Same amount of pins, still 8, so didn't make a difference. Over here I am using some shift registers, and I'm using the 74HC4049. I don't know why I went with that one. I was deciding between that one and the 595. I think the 595 is pretty common. I honestly can't remember why I picked these ones. I don't think it was price, because I think these are more expensive, but I don't know. But it really doesn't make a difference. They're basically the same thing. They work. One thing though, one issue that I did have is on startup. Which was super easy to solve, but on startup they kind of wig out. They send a ton of signals just all over the place, and I didn't want that. I didn't want them just, I don't know, flipping all over. So I can show you that here. Basically each of these LEDs is like a rule being flipped, and then these are the guys that like set a whole bunch of them. These 4 buttons down here, and so on startup right now, it will just set every rule, make sure that they're good. But if we pull out this resistor, on startup, they like wig out, right? And then set every rule. And I think that's just because I have the active, I set the active, what do you call it? The enable. I set the enable low to keep them from not doing that. But I think it's just like on startup, it's floating. The Arduino pin might be floating. I'm not really sure. So I just put a pull down resistor to ground. And I mean, just simple solve. Doesn't wig out. Okay, so I ran into an issue. When I was testing all of this, I was testing it on this power source here, which has a variable, we call it volts, variable volts, and it's got a max of 1200 milliamps. It doesn't have like overcurrent protection or short protection, and so this guy was working just fine, supplying no more than 1200 milliamps for a pair, 600 milliamps each for these guys, and they were working great. However, this is not the power supply that I was planning on using in the end. I was just going to use a regular little 12 volt adapter. So we have one here. This guy only outputs like 2 amps. It does have overcurrent protection. And I don't know if you can see that little like green light in there. When I plug this guy into here, it trips the overcurrent. I don't know if you can see that. So this wasn't working. And I kind of figured it was probably just because the wire's too thick or not enough turns. If we measure the resistance on this guy, it's pretty low. Yeah, it's almost 4 ohms, so it's pretty low. And I really didn't want to use smaller wire just because like winding these things on the pole would have just gotten a lot harder and taken a lot longer. So I reached out to this guy on YouTube, the tinfoil hat, and because he had done some Flipdot 7-segment displays. And I asked him what power source he was using, see if he had one that didn't have like overcurrent protection or anything. And he just kind of, I guess I already kind of knew this, but talking to him just kind of convinced me that I just need to change these things up. So I went with 34 gauge wire, a lot smaller, and did a lot more turns, and that really made a big difference. These guys have like a long list of their ohms and their milliamps, but they're all kind of around, I don't know, 35 ohms. They'll draw roughly 340 milliamps. So this guy was, I didn't actually know how much it was trying to draw because of the limit on my power adapter. So I have this beefier one here. And this guy will supply 4 amps. And so if we take a look at what this is drawing, I'm going to do this for a very short time because it gets very hot very quick. But let me set this up and we'll take a look at what's drawn. Amps. So about 3 amps almost, which is a lot. And it's already pretty hot. And I was wiring 2 of these together, so that's 6 amps. So this guy wasn't working either. It's because I had 2 of these wired together and the overcurrent protection was tripping in. One of these by themselves will work on this, but still it gets very hot and it's not very effective as far as power goes. So yeah, talking to this guy, the tinfoil hat, and I put a link for his channel in the description, actually for this video that I took a look at, but just talking to him really helped me talk me into doing this better. One other thing I noticed that he did that I thought was really cool, that he put out this video that answered a bunch of questions that people had for his thing, kind of in the middle of me working on this. I wanted a solid bar here in the middle so that I didn't have to deal with the threads when I wound these things, and I threaded all these, and that actually took a long time. It was a little bit miserable, but by this guy tinfoil hat, he did this here, which he 3D printed a little thing that goes over his, and all he had to do was screw it on, which I thought was brilliant. Unfortunately, I had already been most of the way through threading these. I didn't have them all threaded, but I had most of them threaded, so I just stuck with it and continued. Everything's already designed for the size of this bolt and like the thickness of this bolt and the washers and all that stuff. So if I ever had to do it again, I would do what he did, 3D printing this little holder thing. Okay, so here's the inside of this thing. Here's the main controller, all the little motor controllers, the shift registers, the electromagnets. This is the multiplexer for the buttons, and that's basically it. So often when I do my projects, I prototype them on just an Arduino Uno, and when I'm done with that, I put them on a bare bones Arduino, which is basically just the 18 mega 328 chip and a clock and some stuff. This thing is, I don't know, maybe a little big and a little expensive, and I only have one to put in like every project I do, and this is way cheaper, so that's what I do. I've never had an issue before. Anyways, the issue I ran into was, so I got the whole thing done and working on the Uno, and I started wiring it up. I put it all in here, and I hooked it up to the bare bones, and it did not work. I spent probably a little over 12 hours on a Sunday trying to debug why, and I honestly could not figure it out. I'm pretty sure it has to do with the multiplex buttons, but I could not figure out why. I don't think this guy has internal pull down. I'm not actually sure, but I had like my own pull down resistors. I tried pull down, pull up. I tried internal, external. I don't know why it wouldn't work, but what I ended up doing was I took this old teensy, because this thing's still pretty big. I guess it would fit in there, but I already had this like board made and everything like hooked up. So I took an old teensy, I think it was a 3.2, and just made this little adapter board for it that'll plug it. I mean, the pin numbers are different, but they're in the same spot as what I had for the 328 chip. The only thing I had to do was reroute the power, which is, it's in there somewhere. This is maybe still a little expensive for this. I will probably continue to try and figure this out, and if I can, I could just drop this chip right back in there. But for now, this is how it is. And the teensy works. So the teensy works, the Uno works, the bare bones does not work. I don't know why, but maybe one day we'll be able to figure it out. Okay, so we'll go over real quick how I made my electromagnets. Basically I took this steel bar, cut off a little piece, and then I threaded them with this threader, and I threaded them just to where the wire would be wrapped around. I don't know, it's pretty simple. Just yeah, I mean, I used a drill. I just attached it into the drill and stuck it in there and threaded them. That way the core is still solid. It gives me a flat surface that doesn't affect, so you can see core is still solid. It gives me a flat surface that doesn't really affect the wire. Okay, so because we switched to the smaller wire, winding these things was a bit harder and took a little longer. I needed more wire, I guess, and just to kind of go back, I didn't make a winding machine, and maybe I should have after going to the smaller wire, but I didn't. And that being, I have nothing to count how many turns I'm doing, so I'm just doing like layers across, and so I'm trying to get these layers as tight as I can so that they're all as consistent as possible going this method. But just gonna kind of go over this one more time. It wasn't too bad, honestly, but it did take a bit of time overall to do all of these. ones do usually get a little, ow, a little kind of messed up, but I think I just cut my finger. But it's pretty even all the way through.